To our class today. My name is Galagash and I'll be taking you through numerical analysis, and this is a postgraduate course for those pursuing maybe masters or maybe their PhD in applied mathematics, and we are looking at Taylor series. We will also look at other methods that we can use in terms of interpolations and maybe approximations. We have Taylor series. We start with the Taylor series, and then we'll proceed to maybe the Lagrange methods. Lagrange method is being used when you are given a table and maybe the values given are not equidistant. If they are equidistant, let's say that you have 4 variables or 4 values, like 1, 2, 3 up to 4, and they are equidistant. That means that the distance from 1 to 2 is 2, or maybe if I take 3, it means that even the distance from 3 to 4 is 3, and the distance from 3 to 4 is maybe another 3. In such cases, we can use the Newton backward or forward in order to solve the given numerical equations. But in the case where they are not equidistant, we will apply the Lagrange method. So here we are going to start first of all looking at the Taylor series, and I have the first question given here. We are supposed to interpolate using the Taylor series. So here you are going to have solve dy dx. You are given dy dx to be equals to x squared minus y, and you have y naught to be equals to 1. So you are asked to use the Taylor series and compute y of 0.1 and then y of 0.2. So I will show you the formula you are supposed to use in terms of the Taylor series, and we'll try as well to solve this using the Lagrange method and maybe Newton forward and backward in terms of this interpolation. Okay, so let's look at what is given. So what is given is dy dx. So dy dx is x squared minus y. This is what is given in the equation. So we are using the Taylor series. So this dy dx can as well be written as y prime, because this shows you the first derivative. So this is y prime is x squared minus y. So this are the same thing. So we can now find the second derivative. So y double prime is going to be, if you differentiate this, you simply have 2x minus y prime, because this is y. So if you differentiate y, you simply get y prime. Let's look at the third derivative. So this becomes 0. So we simply have 2, because 2x, when you differentiate 2x, you get 2. And if you differentiate y prime, we get y double prime. Now we find the fourth. The fourth derivative will give us simply negative y triple prime. So this is what we have here. Now from here, what you ask yourself is why not? We are told that dy dx is equals to x squared minus y. Y naught is equal to 1. So what this tells you, if y naught is equals to 1, then we have y of x naught. Y of x naught is simply nothing but y naught, and we are told that y naught is equals to 1. So this implies that our y of 0 is equal to 1. You need to pay attention to this. So what actually this means is that at some values, let's say at x will be equals to 0, then y or y naught is equal to 1. So when x is equals to 0, y naught is nothing but it tells we can now use what we have already gotten. We have find the first derivative, the second, y prime, y double prime, y triple prime, and y power 4. derivative. So what would be our y naught? Our y naught prime. Our y naught prime, here we have y naught. So our y prime, we have x squared minus y, but you are told that y naught is equals to 1. Y naught is equals to 1. So in this case, we simply have to, when you see x, you put 0, because you see at x equals 0, y naught is equal to 1. So this means we have 0 squared minus 1, because we have 1, so that this is negative. So y naught prime is simply going to give us negative 1. So if y naught prime is negative 1, what is y naught double prime? So y naught double prime is nothing but positive 1, because this is negative 1. So if we take negative, negative, it becomes positive 1. So what is y naught triple prime? Y naught triple prime is also going to give us 1, because here is positive 1, and we have already gotten 1. So you will be using the previous. We have got y1 to be equals to negative 1, so you have to apply this negative 1 in y double prime to get to positive 1. When we apply this positive 1 in terms of what is our y triple prime, because we know here our y triple prime is 2 minus y prime, double prime. So it is simply negative. Negative becomes positive. So we have 1. So what is y naught power 4? Y naught power 4, this is going to be positive, then negative, because we have negative. So it is positive, negative, y triple prime. That means it is negative 1. So you have to pay attention to this. Once you understand what has happened here and how this is being iterated, you are able now to use the Taylor series formula in order for you to find the final answer. So let's now look at the Taylor series formula. So the Taylor series formula says that y is equals to y naught plus, we have x minus x naught, multiply this by y naught prime, plus we have x minus x naught, then squared, divide by 2 factorial, so multiply this by y naught double prime. We add this to x minus x naught power 3, divide this by 3 factorial, multiply this by y naught triple prime. Then we have to do up to 4, since we have up to the 4th derivatives. So we add this to x naught divided by 4 factorial, multiply this by y naught power 4. So this is the formula that we have. After you have done this, you simply substitute. So we have y naught. Our y naught is what? Our y naught is 1. You can take a red color. Our y naught is 1, right? Our y naught is 1. Plus we have x minus x naught. So this is x minus 0, because we know x naught is simply 0. So x minus 0, multiply this by y naught prime, and our y naught prime, we got negative 1 here, negative 1. So you put negative 1, so multiply this by negative 1, plus we have x minus 0 again, squared, divide this by 2 factorial, times what is our y naught double prime. Y naught double prime is plus 1, so multiply this by 1, plus we will have our x minus 0 cubic, divide this by 3 factorial, multiply this by our y naught triple prime is 1, so multiply this by 1. Then we have the last one, which is x minus 0. So we have x minus 0 power 4. Divide this by 4 real. Multiply this by negative 1, which is our, we got negative 1. So now you can simplify this. So let's create a space. You can take this up a bit. Okay. So if I simplify this, I will simply have to, I will get here, our y is going to be 1 minus x, plus here you have x minus 0 is x, so we simply have x squared, so this is x squared divided by 2 factorial, plus we have x cubic by 3 factorial, plus this minus now will affect that, so here you have to pay attention to the signs. Clean that up. So here is negative, the last one, because of the negative sign that we have. So this is negative, so this will give us negative x power 4 divided by 4 factorial. Now at this point we are told that if you remember, we are told that y at some point, y is 0.1 and y is 0.2. We have to compute that, so we need to now apply that. So at y, if I do at y 0.1, I will simply have y is equals to 1 minus 0.1 plus x squared, so it is 0.1 squared divided by 2 factorial plus 0.1 cubic, divide this by 3 factorial plus 0.1 power 4, divide this by 4 factorial. You can plug this in your calculator. You should be able to get approximately 0.905, which is your answer. Now we do again at y 0.2. So I will do 1 minus, that is 1 minus 0.2 plus 0.2 squared, divide this by 2 factorial plus 0.2 cubic, divide this by 3 factorial plus 0.2 power 4, divide this by 4 factorial. So if you plug this in your calculator, you should be able to get 0.822. And this is how you are able to compute some variables using the Taylor series. So the next example now would be for us to apply the Lagrange and the Newton interpolations, where we will use the Newton forward or maybe backward if the values are not equidistant. If the values are not equidistant, we will apply the Lagrange method. If they are equidistant, we will use the Newton forward and backward interpolation to find the numerical solutions.